Before heading to the video, if you haven't subscribed the channel, do subscribe it and don't forget to click the bell icon for the latest update notification. If you like the video, do like, comment and share. Stay tuned with Learnbay.co. Happy learning!
So what is TensorFlow? Anyone has any idea? So as they say in a very simple sentence, if someone has to explain, it's an end-to-end open source machine learning platform developed by Google. Okay. And of course you can use for a lot of things. There is a desktop TensorFlow as well, which can run with Colab or your own computers. There's a JavaScript version where it runs on browsers. There's a mobile and IoT version, which is TensorFlow Lite, which can be run on phones. And there is a production level as well, which is called TensorFlow Extended, which is an end-to-end platform for preparing, training, and validating and models in large production environments. So TensorFlow had got like quite a lot of flavors these days. Okay, and all of them can be run in sync, so they can run on your browser. They can run on your phones or IoT devices. They can also run in your production servers wherever you choose it to. So TensorFlow, I think, was made public in November 2015, and even I started using in December 2015. Although I have shifted to PyTorch a long back ago, still TensorFlow is one of the leading libraries, and in production and in various companies, I think, and even I know this, that in production terms, TensorFlow is much ahead of PyTorch as of now. Although that might change, and it is looking like PyTorch is bridging the gap as we speak. But TensorFlow is kind of coming very close to like becoming the de facto in neural network development, and that's why we have to kind of learn it. Now, fundamentally, what is TensorFlow? TensorFlow is kind of an end-to-end, as we said, but it's like a platform or a framework on top of which you can write your own custom libraries as well. You can write your APIs as well, or you can design your whole software stack on that. Okay. Fundamentally, it's a open source framework for Google by Google for high performance numerical computation. Fundamentally, as you might have seen, most of the neural network is just mathematics. Okay, it's matrix multiplication and everything. So the idea is we wanted, or people wanted, such libraries which provides kind of inbuilt libraries and APIs for a lot of these mathematical computation and designing of a neural network in a very modular way. Okay. Now, it was originally developed by researchers at Google Brain and was being internally used anyways. But in 2015, it was open source for general public as well. And it can run on top of your CPUs, GPUs, and TPUs. TPU happens to be a very specialized hardware by Google, which is called Tensor Processing Unit, which is ideally much faster than your normal GPUs, but it is also costlier. It is right now, I think, according to me, is only available for GCP platforms. They have come up with some few boards. Okay, so I think it is called Google Coral. Let me show you the boards. So these boards have been launched in USA, although they are costly. It's not for everyone, at least, I guess. But yeah, if you can get them in India, that would be really amazing. But these boards are available right now, and you can see it is like $150, so that will be 11,000 rupees according to me. So even I'm trying to get some, but due to coronavirus, no one is coming is traveling right now. So one of my friends is gonna hopefully travel in June or July. So I might get my hands on this. Okay. So these might be helpful really in our IoT development and everything.
So
So
how does this work?
it has a TPU basically. It is will be much faster than your average GPU. So we will put our code in this board and we will connect it with IoT devices. And the idea is all of the inference would be taken care by this board. But unless we don't test it, I cannot say it for guarantee, because you can see right now the RAM is pretty low. Although they will be coming up with 2 GB and 4 GB, so I'm just hoping they come out fast with these kind of boards. And it has a flash memory, means your SD card. You can put a GPA MMC over there. It has a micro SD slot and everything. So let's see if my friend is able to come. I might get one or two boards with me as well, hopefully soon. Okay. So what I'm saying is, so Google has kind of led the development of deep neural networks from like in 2014 onwards, and it has like produced a lot of good models, even some really state-of-the-art networks and data sets as well. They have published like a lot of data sets which they have used internally as well, and they have developed TensorFlow, which happens to be again one of the leading ones. But again, said that it doesn't mean TensorFlow is only one of them. Okay, so TensorFlow is just one of them. Okay, there are a lot of other libraries, which like PyTorch is like one of my personal favorites, and Microsoft has come up with CNTK. Cafe 2 is there. This is by UC Berkeley. MXNet is by Amazon, if I am remembering correctly. It works with a lot of languages. MXNet, if you want to make it work, so if you want to work with C Sharp, CNTK is the way to go. Now Keras has been bought by Google, so it is these days it is like TensorFlow plus Keras. It is not even different terms. It is literally become the same library. And I might take an approach where I will go with TensorFlow plus Keras, not two separate libraries, as a single idea now. Okay. So TensorFlow plus Keras is now Google basically, and PyTorch is maintained by Facebook. So PyTorch is also pretty good, and we will cover some basics a bit later. Okay. So there are a lot of other libraries, but TensorFlow and plus Keras are leading in the production environments, and that's where we are going to focus on them as well. The first focus would be to cover TensorFlow plus Keras. So, of course, some people might think about installing it. Now, you can install it, no problem, but there are two variants of it. Okay. Now, unless you don't have your NVIDIA card with CUDA cores on your systems, you should not try to install TensorFlow GPU version. Okay, that would not work. You should install by default TensorFlow. So TensorFlow by default version is CPU, which runs on your Intel CPU or AMD CPU itself. But unless you do not have NVIDIA GPU installed, do not try to install NVIDIA TensorFlow GPU. It will throw out errors later. One of the most simple ways to install is pip install, of course. Pip install upgrade pip. Just make sure you have latest pip, and then just do pip install TensorFlow. It will get the stable release for CPU and GPU. It will detect the settings, and accordingly it will download or install CPU or GPU variants. Best one would be according to me. So this is a crash course kind of stuff. Okay, so the best way to kind of run this whole thing would be, one second, let me run the whole thing. Okay, to run on Colab. Now on Colab, TensorFlow plus Keras come pre-installed these days. Okay, so if not, you might have to install this, but if yes, you can. So if it is not available, it will install it immediately. Okay, most of the requirements are already satisfied, as you can see. Okay, I think it already found 2.2. Okay. Yeah, internally it might have updated this whole thing. Maybe I should not have. Okay. Again, it is being happening on mine. So maybe on yours, you should not do this pip installation because then already everything is there. So right now we have got a Tensor board and TensorFlow 2.0. Although again, if I rerun it or if I just reconnect it, I might have TensorFlow already installed TensorFlow 2.2. What just happened? 2.0.0. Okay. So the creator of Keras, Franco Chole, basically published this, and I was quick to kind of make a copy for myself just to kind of run it. So we will cover this a bit later, not today, just to explain you that how we can do this. And a lot of the code has been basically kind of merged, and now Keras and TensorFlow are not running separately. Now Keras is very much running with TensorFlow these days. Okay, so we will cover this a bit later, but this is a very good kind of execution and the way it is done. Okay, so first let's go through basics, and hopefully by the next class, we will be able to cover the file that I showed you. Okay, why do we use TensorFlow? What are the advantages? First, it is highly flexible. It is first of all very modular, which it means is once you can develop this in a desktop and you can put that in your production level server, you can put that on your phones, and you can put that on your browser as well. So because of its high modularity, it is easy to pick parts or the all the parts, and you can deploy it in various other environments. Portability, again, as I just said, it can run on various different hardwares, GPUs, CPUs, desktop servers, and mobile computing platforms. Uh, it is equally good for research and equally good for production. Okay, you can use to train and serve models in live mode to real customers. So the idea is once I write the code and the model, I don't have to rewrite the code. Okay, and you can do the research on the code, and we also do this, like we write the code for research purposes, and even when we have to show the POC, we literally pull the same model, put it in a production environment with Django and stuff, and we just make the model live, and it starts to work. There is no differentiation, no different approach here. Okay, auto differentiation. Now this is very important. So see, we had to calculate the differentiation forms, and we need to know a lot of differentiation forms. TensorFlow and even PyTorch has automatic differentiation capabilities, which basically means you can run backprop end to end without doing any differentiation on your own. So you don't have to do any differentiation on your own. It will be taken care of automatically. So by the network or by the library, it takes care of the differentiation internally, and you don't have to worry about differentiation at all. Now that's a major headache of your heads. Like otherwise, it is a really tricky problem to do all of this on by your own. Okay, and performance. Of course, it allows us to make most of available hardware. It allows for threads, asynchronous computation, and queues. So whatever you want to assign, just assign the element, and TensorFlow graph will take care of different devices and let it manage all the copies by itself. It also facilitates us with language option to execute your computational graph. Now I will be showing just few use cases of TensorFlow. Of course, a lot of use cases have been, or a lot of places people are using TensorFlow. Deep Speech, one of the Mozilla tools, which is for speech recognition. So they have used TensorFlow, which was kind of used Deep Speech, which was developed by Baidu, another search company based in China. And they kind of developed this based on deep speech and implemented in Mozilla Firefox. There is RankBrain, where Google is doing this for their own ranking algorithms. So basically, it's a large scale deployment of deep neural networks for search rankings on google.com. Then you have Inception image classification model. So Inception image classification is like very well known for us. So even they have come up with image object detection API. So object detection API. Okay, in TensorFlow. So they have just used this. The whole code is in TensorFlow. Okay, and if you want to go here, so you can find there are various communities and there are various projects. So I think the TensorFlow 2.2 is there. So I think now we should all look in TensorFlow 2.2 itself. And of course, if you want to check it out, the forums and everything. Yeah, the other good thing is the forums are extremely responsive, or the Google groups that they have made are extremely responsive. So if you face any kind of problem in TensorFlow, just find the answer. You can find the answers really fast here, and people are very active to kind of help you out. So this is one thing that I really like about this, and this project and the way they have maintained everything. And again, as I just said, it's extremely well built and extremely well supported as well. And as you can see, as I told you, Google has been leading in production of even data sets. So there is a lot of data sets that are readily available, which you can utilize. Okay, and you can run these data sets extremely easily in Keras as well as TensorFlow. So the community is pretty good and it's highly responsive. Data sets and the models are freely available. And there are so many other add-ons. You can implement it with iOS and whatnot. So there are Swift APIs. So Swift for TensorFlow Deep Learning Library. So Swift is a coding language used by iOS developers now. So if you want to integrate TensorFlow with Swift or iOS development, you can do it. Similarly, you can use a probability module. So there is a probability module for TensorFlow as well. So anything that you want, anything as special functions that you want to do with TensorFlow, almost all of the other separate libraries are also equally available and almost everything is free right now. So I personally really like it, and you can see Swift for TensorFlow, Swift models as well. So Google has worked really very hard to make this accessible to all of us. And this is why it has taken lead, because Google has pushed it so hard, and it has made it production ready from literally I think day one. So this has really helped us a lot, and even I have developed in TensorFlow a bit, although not that much. I'm not doing that much TensorFlow these days, but again I understand how this works, so you are in good safe hands, I guess. Okay. And in this website you can find like a lot of examples, and there are a lot of good courses on Coursera as well, where you can go and check it out. Okay, so you can go and you can find some TensorFlow examples which run very well. So you can check the models, and with these models you can run some algorithms, and some DCGNs are there. Now most of the code has been converted to Keras already, so this is the approach even I will be taking now, that rather than going completely TensorFlow idea, we will be mostly going in the TensorFlow.Keras systems, because it has been easier now to write those codes, and even TensorFlow is like pushing us in that direction, that we should start looking coding like that itself. Okay, all right. And again, you can see a smart reply. Have you seen the smart reply by Google or Gmail?
Yeah.
Yeah, so that has been used to a deep LSTM model, which automatically generates automatic email responses. And they have worked with Stanford University to do a massive drug discovery. And they have also tried to do on-device computer vision for OCR. So there is a good tool called Google Lens, I guess. I will recommend you to use it once. So install this one. So
Lens we have used. Yeah.
yeah, you have used it, right? So you can do a lot of things, and it does OCR as well. So if you go here, see, it does OCR, and it also tells you what it means. And again OCR, and it can figure it out what is it is saying. Is it kind of a ticket or some kind of calendar event? So Google has done really good with Google Lens, and you can give it a try. I have already installed it and already use it time and again. Okay, so today I would like to stop here. In the next class, we are just going to continue with TensorFlow, and mostly TensorFlow plus Keras. The code will be mostly TensorFlow plus Keras these days, because we are trying to move into the next generation of the coding. TensorFlow 2 is more like less of TensorFlow, more of Keras on the front end, at least when you look at it. Okay. Meanwhile, I would like you to solve the assignments in meantime, and send to my email. And I would really prefer if you guys can do it on Collab. It is easier for me to like check and kind of verify. Otherwise, I have to launch Jupyter and then start and check anything. Okay, so it would be much easier to do if you can send all of this on Collab itself. Okay. All right, and I'll also be sending you this file, so that in advance you can go through this file as well once, so that because we are going to discuss this file in the next class. Okay, all right.
One question.
Sure.
So, like, everyone says like we should know calculus, and so we will be using calculus further also.
As basics, there would be some basics which will again require calculus, but only till like while the explanation is going on, so that like look, if you knew chain rule and partial derivative, wouldn't that help you in understanding backprop better?
Yeah.
That's the reasoning. That's it. People can learn without understanding calculus as well, but their learning will be highly superficial. It will be on a very high level. They will not be able to explain you like if you do not understand calculus, you cannot do it this line by line stuff. You can use maybe some function in Keras, but you cannot write this code and you will definitely not understand how this code works. You cannot solve all of this if I were to give you this, which I am going to give you today. How would you understand what does it means? What
Yeah.
am I doing here? So that's why the calculus is required. I'm not saying you have to do it by hand. Of course, that's why we have computers. But a lot of code or a lot of basics will not make sense till you know all of this stuff, step by step.
Okay.
Okay, so some basics again simple. Differentiation, partial derivative, chain rule, and some small integration. That's all it is required. Nothing very heavy or nothing very high double differentiation or nothing like even like differential equation, nothing like that. Some basic calculus is required. That's all, which most people have done till class 12th already. Okay, if you were in maths, you must have done calculus till class 12th, and that is more than enough here.
So Amritansh, what all you told? Differentiation, partial, chain rule and partial derivative.
Yeah, let me repeat it. Differentiation, integration,
Okay,
and in differentiation, partial derivatives as well as the chain rule.
okay,
That's it.
that's it.
Yeah, nothing very advanced or special here. Okay, the basics are more than enough for you.
Yeah, we did, but actually you don't use it right anywhere. So now,
Sorry.
like this all is done in usually engineering mathematics and all that,
Yeah,
but no one uses it, right? So it's gone.
depends which domain you are in. I have to
Yeah,
use it time and again. If you were to do anything in spiking neural networks or anything over there, there is a lot of differential equations to solve. So depends which domain you are in. But yeah, in general, day to day, yes,
in
you can
general,
definitely
I'm
use it.
talking like
Yeah,
because
yeah,
you
of
are
course, of course.
specific. Yeah,
Yeah, mine, of course, mine is very specific.
yeah.
But yeah, in general, of course, you are not using it. No, although even that is not true because of the so many abstractions you have. But yeah, in general days, yes, you don't have to use it. Okay, is that all?